Okay, so this is how LlamaIndex works. It works in two ways because LlamaIndex is a RAG orchestrator, and it works in terms of ingestion and retrieval. Now, ingestion is this way. So, LlamaIndex takes documents, your data, it could be PDF, TXT, or web pages. It takes your documents and it chunks them. Now, chunking is that it takes them and splits them into bits and pieces that will fit an embedding model. And embeddings are generated based on those pieces from your documents, and then they are sent to a vector database. Now, a vector database does not store data. It's a regular database that it saves your text as text, and it saves your image file as image file. Instead, it saves your data or your document as a list of numbers, which are called vector embeddings. Now, that is the first part of the ingestion. Now, LlamaIndex also does the retrieval part because it's a RAG orchestrator, and it does it in this way. So when a user makes a request, you ask a question like what is this document all about, the document that you have previously saved on your vector database. When you ask that question, it takes your query and it turns that into a vector embedding, and that vector embedding is used to query against your vector database, and it is used to search for other vectors that are similar to that your vector embedding. This is where similarity search comes into play, and this how it works in a simple way. And then after it uses your embeddings, it retrieves what we call chunks, and these chunks are vectors that are similar to your own vector, and it sends this to an LLM. This could be GPT, it could be Claude, it could be Gemini, whatever LLM that's used. So it sends this to an LLM, but it sends it as a vector embedding, or it sends it as like chunks, and the LLM converts that vector embeddings or convert that chunks to a natural language, and it gives it back to you. This is how LlamaIndex works as a RAG orchestrator.